Okay, here we go. So let's just go through, I just pulled up practice test. Let's just go through everything. Okay, so first one here, they want us to use implicit differentiation to find dy dx. So let me grab the problem. You guys can walk me through this. Okay, so what do we do? If we would use, they tell us to use implicit differentiation, but you know that anyway, because the x's and the y's are all mangled up, right? We can't just isolate y here. So what do we do? Okay, let's go ahead and just group the 2 with the x squared, and let's group the 9 with the x. How about? Okay, and then what do we get? So product rule, isn't it? Good. So here, when we differentiate this first term, we've got to use, there we go. We've got to use the product rule, right? And so, remember that one's easy. It's just going to be the first factor times the derivative of the second plus vice versa, right? So we get 2x squared times, what's the derivative of y? Y prime, because we're differentiating with respect to x. So there's a y prime. Okay, plus, now we got to flip it around. Y times the derivative of 2x squared, and what's that going to be? Just a plain old 4x, right? Only one layer there. Okay, plus, and then now we've got another product rule, don't we? So we get first, which is 9x, times derivative of the second. What's the derivative of y squared with respect to x? Good. So 2y, y prime. When you get this, that's good. Plus y squared times the derivative of 9x. Good. Equals, and then the derivative finally of 2 is 0. Okay, good. So all we got to do, calculus is done. All we've got to do now is just isolate y prime, right? So we'll put all the y prime terms on the left, how about? And all the non-y prime terms on the right. And while we're doing that, we'll clean things up. So this first term ends up on the left then. I've got a 2x squared y prime. I've got another y prime term here. I'm going to get what? 18x y prime. And then we'll push all the other terms to the other side, all the non-y prime terms. So I'm going to get a minus 4xy from this term, and then a minus 9y squared from that one. Now what? Factor out of y prime, good. And we're left with what?
X squared plus.
There's this stuff. And then finally, just divide each side through by whatever the leftover factor is after I factor out of y prime. So we get y prime equals this. That's it. Question?
When you're first differentiate,
Up here?
it'd be like 2x squared. It's not y.
No, because we're just differentiating y, so there's only one layer. See the difference? If I'm just differentiating y with respect to x, well, that's dy dx. That's y prime, right? Over here, though, I'm differentiating y squared. And so I've got 2 layers there. I've got the derivative of hand squared is, did I forget the 2? No, that's over here. Here it is, 2y, right? 2 times y to the 1. So there's the first layer. The derivative of hand squared is 2 times hand to the 1. times the derivative of what's inside is the derivative of y with respect to x, which is my y prime. Okay, so I need both of those layers there. Okay? Other questions on that? Yes?
Whenever you get down to the end, you ever going to be able to simplify, or is that always too messy?
Well, I mean, if you had, I mean, there's not much you can do. You could potentially, I mean, you might be able to. Like, what if I had an x there? I could have factored out an x on the top, and maybe there was an x on the bottom. I could have factored out an x on the bottom and canceled them, right? But right now, there's nothing I can factor out of the top and the bottom that'll cancel. So there's no reason to really do anything. If I had like terms, I could combine like terms. But it's kind of different every time. Yeah. Okay, so next. Do I have to like check my answers here, or can I just?
You go.
Not if you're,
I can just go? Okay.
Yeah.
Yes, I want to leave that question. Okay. Maybe I can't. So I can just put in something bad, right? Like that. There we go. Okay. Man.
I feel you.
Yeah.
Wasn't expecting that.
Okay, let's try this one. Okay, so I know the question says use the given substitution, but I changed these questions so they don't give you the substitution. But it's pretty obvious. What's going to be, just take a look at this one real quick and think what you're going to do here. If we're going to, if we're going to differentiate using the chain rule, what are the layers going to be? How many layers do we have? 2 is correct. Good. Okay, we're good. All right, so then if we differentiate dy dx or y prime, whatever you want to call it, what's the first layer?
Sine.
Sine. Okay, what's the derivative of sine hand?
Sine.
Okay. Okay, now don't make the mistake, because this is real common. A lot of times people make the mistake of just putting in whatever the derivative of hand is inside here, but we don't do that yet, right? The derivative of sine hand is cosine of hand. The hand part stays the same. Now, we'll go to the next layer. Inside the sine, we've got an 8x plus 3. What's the derivative of that? 8. Okay, so we need 2 links in that chain then, right? Because we have 2 layers. And so our answer, all we would do is put the 8 out front. That's it.
Yeah.
Okay, question?
There was a square there.
If there was a squared, like right here,
Yeah, or on the other side.
or, okay,
It
yeah,
was the same thing.
it'd be, well, it wouldn't be, but it'd probably be there if there was gonna be a squared, I'm guessing, to this one. So that would mean, then there'd be an additional layer. That would actually be, that means the sine of 8x plus 3 quantity squared. So now we'd have an outer layer that would be hand squared, right? So what would the derivative be then? Good, 2 times sine 8x plus 3 to the 1. Then we'd have to start where we did on this one. Now we differentiate inside, and the derivative of sine is cosine. So the only difference would be, in front, we would have an additional 2 times sine of hand in front, because that would be the first link. Okay? But I'll take this stuff off. There. Okay? Ouch.
Dang it.
Okay, so what about this guy then? It's product, isn't it? Yeah, it's product rule. I've got an x cubed times hand to the 7th, right? So if I want to find y prime, then I'm going to use the product rule. So I've got the first times the derivative of the second. Okay, what's the derivative of the second going to be? What's the first layer?
7.
Good. Get 7 hand to the 6. So the first layer is 7 hand to the 6th. And hand is 2x minus 3. And then what's the next layer going to be? If we look inside that. 2. Good. Okay, plus, now we flip it around. So now what goes first?
2x minus 3.
Good. Times the derivative of the first. That's it. Calculus is done, right? Now all there is to do is just clean this up. Okay, so let's first of all, let's clean up each term. So this first one, I've got a 2 times a 7
Where does that 2 come from again?
from the derivative of 2x minus 3. So we get a 14 x cubed times the quantity 2x minus 3 plus
To the 6.
3x squared, oh, to the 6th, yeah, times quantity 2x minus 3 to the 7th. Okay, so now what? Okay, good. So we're going to try to find greatest common factors. Well, there is no, the greatest common factor of 14 and 3 is 1, so we can't get a number out of this, right? But we do get, if we look here, I've got x, I've got x's, I've got the base x, right? So we could pull out front the greatest common factor, meaning the smaller of the two exponents, right? So x squared, and then I've got those, right? Good, times
2x minus
2x minus 3 to the 6th. And then what's going to be left over if we do all that? From the first term,
14x
14x.
14x, good, that's it, right? Okay,
plus
and then we get our plus,
3.
good. Okay, questions on that? Let's pause there for a second. Almost, we're just going to maybe clean up inside the brackets, but that's it, yeah. Okay, any questions on that? Well, we've done that. Okay? So then last step would just be, now what can we do inside the brackets here? If we distribute the 3, we're going to get a 14x plus 6x is 20x, and then I get a minus 9. So now we're done. Questions? Okay, so what about something like this? Now they're asking us to, we've got this problem where we're not going to bother trying to solve for y because the y is being squared. We just want to find the first and second derivatives implicitly. Okay, so what do we get then when we differentiate the first term with respect to x?
2y.
Good, 2y times y prime equals, okay, right? That's it. So all I got to do here is just divide each side through by 2y to solve for y prime. Okay, so and then I could factor a 2 out of the top and cancel the 2's. What's that going to give me? There we go. Okay. So there's part 1, right? So that's y prime. Okay, now what?
Take it, differentiate, right?
Okay, good, and we have a choice. We could either just differentiate here if we want to, or we could go up here and I could maybe cancel a 2 out of this and just make this a y prime equals 9x minus 2, and then just differentiate from there implicitly. If I just divided each side by 2, that's all I did. Right? I mean, that's fine. You can do either one. It doesn't matter. And you don't even really have to do that yet, but it's just nice to. It's nice to trim it down if you can. I think most people are, right now at least, probably more comfortable just starting here.
Yeah.
Does that work?
Yeah.
Okay. But real honestly, I would probably do it this way. I mean, just because I don't have to use the quotient rule then, but.
So if you just start there and then you get rid of the fraction.
Right, we'd have to use quotient rule then, wouldn't we? Right? So if we're going to differentiate this, let's flip this around. And we'll have, on the left side, let's put our y double prime. So we flip it around. On the right side, we're going to have the derivative using the quotient rule. Okay, so what's that going to be? Low D high, good, so I've got a y times derivative of the top, which is 9, good, minus,
9x minus 2.
good. There's my high, D low, good,
Over
Right.
y.
good, yeah. And what are we gonna do? Divided by y squared. There we go, okay? And so that's it. Only difficulty here is, I want my answer in terms of x's and y's, and I've got a y prime in there, so what do I do? Good, okay, so we know that that's y prime, so we'll just make that substitution, right? Okay, and then, so let's see, what do we get if we do all that stuff? So I get y prime equals 9y minus the quantity 9x minus 2 times 9x minus 2 over y, all divided by y squared.
Why are they both?
Can we plug in the y squared?
Okay, so the question was, why are they both on the top like that? They don't have to be, but when I multiply fractions, I multiply straight across. So you could put the bar under just this or the whole thing, doesn't matter. Same diff, right? So yeah, so what am I gonna do either way? Question real quick?
Well, is there any advantage in putting the y squared back into the problem? Because we already know what y squared is. We know it equals 9x squared minus 4x.
That's interesting. So, I don't think so. I don't think so, and here's why I'd say no. I mean, it's a really good idea, actually. I think it's a really good idea. The reason I'd say that it's probably not that big a deal is we're going to end up getting stuck with at least one y in there anyway, and so you might as well just leave them all. If you could have gotten rid of all of them, that would have been kind of cool to do, because then you could have had your answer in terms of a single variable. Yeah. Okay, so now this is really just some algebra here. What do we do in a situation like this? Got to get a common denominator, don't we? So I'm going to multiply this fraction by y over y to get a common denominator. Okay, and then what do I have? So then I've got, if I do all that stuff, we've got on the top, I've got 9x squared minus 9x minus 2 squared, right?
9y squared.
Oh, 9y squared, whoops, you're right. That's got to be a y. Okay, good. Over my common denominator of y, right? All over y squared. But what we'll do is we'll just multiply by the reciprocal of the denominator, like that. Okay? And so our final answer then, if we just multiply straight across, we just get 9y squared minus the quantity 9x minus 2 squared over y cubed. Okay, do we need to expand that out? I would say no. I don't think there's really.
Wait, can you-
Sorry?
Do it your way.
so
man.
you square it or like square root, make it 3 multiples?
No, you can't. You can't because that's not true. The square root of what you're suggesting is that the square root of a squared minus b squared is a minus b, but it's not,
Oh,
right? A squared minus b squared is a minus b times a plus b, right? So no, we can't do anything like that. This is probably as far as we could go. The only potential other move you could make would be to expand this out, but I mean, there's really not a lot of value in that. Let's put this in. I actually want to put this one in and see. I just want to see what the test thinks about this if we just leave it like this. So let me. Okay, just so I can see what's going on, I'm going to put it over here for a second. So we've got y prime we said was 9x minus 2 over y. And then second derivative is 9y squared minus the quantity 9x minus 2 squared divided by y cubed. Okay, so that, right? Okay, yeah, so it's fine. They didn't expect us to expand all that stuff. Okay, it shouldn't.
How would
12
your,
minutes
Wait,
and 2 questions.
how would
We can
your
do
way would have changed it if you had just gone with the y prime equals 9 times 2? If you had differentiated from there rather than,
If we had done, you mean if we had done this thing over here?
Yeah.
Wouldn't have changed it at all. Would have been exactly the same answer.
like, how would the process?
Oh, it just looked like on the left side you'd get a product rule, right? So you could get a y double prime plus y prime times y prime. There's your y prime squared. See what I'm saying? On the right side you just get a 9. Trust me, it would have worked the same way. It would have been, the algebra path would have been slightly different, but it would have worked the same way. You know, it's probably, it might just be safer to use the quotient rule though, just because then you don't have to simplify this at all, right? It might just be easier just to use the y prime you had from before. But either way will work, you know. Okay, so let's see, next here then. So this guy, okay, this would be a good one, yeah.
Just happy those ones were multiplied together.
Yeah, that would have been kind of ugly. Okay, so once again, we're just gonna, actually in this case, we're just differentiating it. It's an explicit function, but we're gonna have to use a little chain rule, right? So one thing you might wanna do, at least in your mind, and this wouldn't be a bad idea like on the paper and pencil test, you wanna show me everything, right? So you can get as much credit as possible. On that one, it might not be a bad idea to write this as the quantity sine x to the negative 5, because that's really what that means, isn't it? Right? Minus cosine of x to the 5th, right? So now if we do chain rule, what do we get? So we're going to get y prime equals, what's chain rule give us for this first one? What's the,
Negative 5 sine x.
okay, so yeah, we have hand to the negative 5. So what's the derivative of hand to the negative 5?
Negative 5 and to the negative 6.
Okay, and hand is just sine x. So then the second layer, the derivative of sine x is,
Cosine x.
okay, good. So then There's our minus sign, so we can track it. And then over here, we've got hand to the fifth, right? So the derivative of hand to the fifth is
5 to the 4th.
times.
Negative sin x.
So then all we've got to do is just clean this up, right? So we've got what, a negative 5, sine x to the minus, so negative 5, you can do it this way, cosine x over sine to the 6th of x. You want to do it that way?
Okay.
Right, because that's the same thing as saying something to the negative 6 moves it to the bottom and makes it to the positive 6. Right? And that the shorthand would just be sine to the 6th of x means sine of 6 quantity to the 6th. Right? Is everybody okay with that?
Yeah, and then it would be
Minus 5 plus, actually,
Yeah.
right? Plus, because we get minus times minus. Sine x cosine to the 4th of x, right? And so, I mean, that's fine. Do we want to, I mean, I guess we could factor out a cosine if we wanted to. We could, I mean, if we want to, we could take out a sine too. Should we just see, I'm just curious, what do the directions say on these? I just want to know. Are they asking you to simplify this too? Find the derivative. Should we just put this in? I'm just kind of curious what happens if we just put this in.
it'll work. Sure.
So, negative 5 cosine x divided by, sine to the 6th x plus 5 sine x cosine to the 4th x. Okay, so this, right? It's fine. So in other words, my point is just on there, you don't really need to worry about trying to do any kind of fancy simplifying on that, right? Should be fine, yeah. If you do, just be careful when you simplify it, just don't make a mistake, yeah.
Can you take that sine 6x and put it on the top as a negative and it would still work? Because that's how it worked in all the practice ones.
Oh, yeah, I guess you could. It didn't say write them in terms of positive exponents, so you could. Yeah, you could just write, that's fine.
Can you still check that?
Can I still check it? Can I check it again if I change it?
Yeah.
Okay. So, can I just delete again? Will it go? There we go. Oh. So what was it? 5? Negative 5
Sine
Oh,
x.
sorry.
Sine negative 6x.
sine negative 6x cosine x. Okay? Yep, it's fine. Okay. All right, so last one. So what about this then? So we'll just do the tangent being as the norm. I mean, really they're the same question. If we have time, we'll do both. But how much time we got? 4 or 5 minutes? I think we can do it.
It's got a rush.
Okay, so so then we want to find the tangent line, right? So we have a point of tangency. All we need is y prime, right? So we'll differentiate implicitly. That's a product, isn't it? Right? So we're going to end up with first factor times derivative of the second. What's the derivative of the second?
2y.
Good. Plus,
Wait, no, that'd be
Another
2
y
y.
in there.
It'd be a what? 2
oh, whoops, I forgot, yeah, what did I do? 2y, y prime, yeah, don't make that mistake. Plus y squared times 2x equals 0, okay? So I could divide each side by 2, right, and get rid of those. And then I would just get x squared y prime plus x y squared equals 0. So if I isolate the y prime, I'm just going to get negative x y squared
Over x squared y.
over x squared y. And I could simplify that, right? I could cancel an x top and bottom and a y top and bottom and just end up with
Negative
negative
y over x.
y over x. Everybody see that? Okay? Right, because I could cancel, I could do that, and I could do that, right? Y squared over y is just y. X over x squared is just x on the bottom, okay? So now, I just want a slope then, right? So when, at this point, at -1, -6, y prime is what? We're gonna get negative 6 over -1, so I get -6 is my slope, right? So then the equation of the tangent line, I would just get by using a value of x and y, right? There's a solution, and I've got my slope. And so all I've got to do is just solve for my line. Y equals mx plus b. So y equals -6x plus b. I could solve for b by plugging in, what are the point, -1, -6? -1 for x, -6 for y, and that's going to give me -6 equals
Please excuse the interruption.
6
I'd like to call
plus
down the
b.
next 5 Rug Pride winners. I would like to call
B equals
Tiana
-12.
Raymond, Maggie Scanlon,
Does that make sense?
Michelle Grove,
So,
Brooke Lapp, and Ashley Bloom. Rug Pride winners. Again, that's Tikiana Raymond,
tangent
Maggie
line then is
Scanlon,
just y
Michelle
equals
Grove, Brooke Lapp,
-6x
Ashley Bloom. Please come to the office to collect your prize.
minus 12, right? Okay? And then if I wanted to find the normal line, finding the normal line would be almost the same thing.
You just use 1/6.
Now I've just got the slope is equal to the reciprocal of the opposite reciprocal of -6. So it'd be positive 1/6, right? And then I would just have y equals 1/6x plus b. And to find b, I would once again just plug in my solution, right? The point of tangency. So -1 for x, -6 for y. And what's that give me? -6 equals -1/6. 1/6 times -1 is -1/6 plus b. So b would be -37/6? No, -35/6. I've got -36/6 plus 1/6, -35/6. And so my normal line would just look like y equals 1/6x minus 35/6. How about that? Sounds pretty good.